Ionic compounds, Part 1, Metals and Nonmetals. Science 10, Chemical Reactions, Video 3. Metals and nonmetals. When we put metals and nonmetals together, they make a metal and a nonmetal with an "ide" on the end. For example, we have potassium and oxygen. When they come together, they make potassium oxide. Similar, sodium and chlorine make sodium chloride. Naming metals and nonmetals, the rules. Metals always come first. Metals always are positively charged, and they're known as cations. Whereas our nonmetals come second. They're negatively charged. They're also known as anions. And nonmetals end in the word "ide." So carbon would now be carbide. So we have steps when we're naming metals and nonmetals. First, we need to identify the charge for each element. So, for example, we have lithium and selenide. So, lithium has a charge of +1, and selenide has a charge of -2. Now, they're not even. We need to make 0. So we need to have more lithium because I need to make 0. How would I make 0? Well, I need -2 and +2. But since I only have 1 lithium, I really need 2. Because 2 times 1 is 2. And 2 times 1 over here would be -2. So that's how I make my 0 charge overall. Now to write the correct formula, I write Li2 Se1. Note that I don't include this one because it's assumed. The word formula would be lithium selenide. This is where you can find most of the charges. You will get a chart, or you should already have a chart, and on the back it has a list of cations that are positively charged and anions which are negatively charged. If you can't find the charge there, then you need to look on this page, and this is our representative. So if your element falls anywhere in group 1, then it is a charge of +1. Group 2, +2. Group 13, +3. Group 14 is ±4. Group 15 is -3. 16 is -2. 17 is -1. And no charge for 18. So let's do some examples. So let's look at calcium and iodine. What are their charges? Well, calcium's +2, iodine's -1. Therefore, I need more iodine. So my overall charge needs to be -2 +2, because that gets me 0. So I don't need any more calcium, but I do need 2 iodine. So my formula is CaI2. Word formula would be calcium iodide. Let's do another example. What if I'm aluminum and bromine? aluminum has a charge of +3, bromine's -1. Therefore, my overall charge has to be +3 and -3. I don't need any more aluminum, but I do need 3 bromines. So therefore, I have AlBr3, which is known as aluminum bromide. Okay, so let's do a one that's a little bit harder. And we'll do Mg and phosphorus. So the charge for Mg is +2, and the charge for phosphorus is -3. Well, what do I do now? I can't make a charge of 2, I can't make a charge of 3, but I can make a total charge, overall charge, of +6 and -6. 2 times 3, 2 times 3. So, how many magnesiums do I need to make +6? Well, I need 3. If I multiply those two numbers together, I should get +6. Same for phosphorus. I need to make -6, so I put a 2. Multiply those together, and I get -2. Therefore, my formula is Mg3P2. And this is known as magnesium phosphide. Now, let's go from the word formula to the chemical formula. So, if we look at beryllium oxide, what's the charge of beryllium? Well, beryllium is Be +2. Oxygen is O -2. Oh, look, I've got +2, -2. Therefore, I can write BeO. Let's do one more example. Let's look at boron chloride. Boron is B +3. Chloride is Cl -1. Overall charge has to be +3 -3. Therefore, I need more chlorine, and I need 3 more. So my formula would be BCl3.